Hello, everyone. So we have a last session before the lunch, and I want to introduce you to the next speaker. He is Maxim Danilov, and his presentation title is "The Art of the Yield." So please.
Thank you. Can you hear me? Yep. Sound check works. And hello, everybody. I'm very proud to be there the second time. And I have experience from many other Python conferences. And I can say PyCon Lithuania, it's amazing and one of the best conferences of Python in Europe. Mostly I speak German, that's why sometimes you can hear German words. Sorry for that, but I try to use English words. And today I want to speak with you about yield patterns, how I can use yield patterns in Python. And my subtitle of talk, I offer you to stop use return statement in your code. How it possible in my talk, and right now who I am. My name is Maxim Danilov. I'm Python and Django developer through many years, and I love to use reactive frameworks for front end. And also I'm a mentor for new Python developers. Last year I spent around 6,000 minutes in a year. It means 20 minutes in a day, every day without any break. And yeah, you can also find me, find my free time for you if you have an obstacle in Python code. Okay, before I start, I want to say special thanks for my family for the support. Thank you for my wife Elena, thank you for my children Mark and Maya, and thank you for my animals Kisa and Marcel, and especially a special thanks for my children who created illustrations for all my talks last 2 years. Thank you, Mark and Maya. And once more time, why not to use return? Because in large distributed Python code base, debugging for returned results takes less time than debugging for unexpected side effects. And that's why if I spend more time to debug side effects, probably if I throw away testing of return values, probably I get more time for debugging. And my reason to avoid returns is clarifying, because right now in my code, the events and state changes, they are explicit. I describe or I declare what should be done in my code. And I increase readability of my code. But of course, you should know how you can learn this code after that. Of course, important thing, it's decoupling. Because my code is not more binded with struct of returned value, because I don't care about returns. Testability. Testability is important because right now I test only events and state changes. For me, it completely don't matter what my function returned, which value returned, because I don't return anything. Concurrency. Concurrency because I don't need to await returned value. I write the concurrent, multi-threading code on fly. And streaming without any return, and if I use the special technique to data processing, I can stream results incrementally. Before to understand how to avoid return, a little bit about return statements. Return is basic syntax in Python language. Python always return value from functions or method. Don't matter if you omit return line, Python adds this line on the background. It means if you write return known or if you write simply nothing, return none appears in your code before converting in machine code. If we can see two stupid example, on the on the left side you see the function which returns something. On the right side you can see function which return nothing. In this case the return line is omitted, but on the in code you can see return still exists. And it's first problem in Django, in Python, sorry. And the second problem, the return is not always return. If you write return line, on the background in generators or coroutines functions or methods, if you write return value accordingly to PEP 380, return value will be transformed in raise stop iteration value. And this PEP described return value is semantically equal in generator functions or methods like raise stop iteration. But PEP 479, all stop iteration is equal, but some stop iteration are more equal than other stop iteration. And if you run these two examples, you can see on the left side you got exception stop iteration value. On the right side you got runtime error stop iteration value. In this case, this is different behavior and more criticism about PEP 479 you can see in my talk, because I think this is a big error was implemented with this PEP. But who I am? I'm only a developer. Summary for return explicit return statement. We can avoid using return, but this is not a rule. Return with inline computation works faster than return then compute something and return after the value. And in C Python, return none is not optimized. It means if I don't return anything, I still spend some commands, some time to return none. I don't like it, but what I can to do. And only to send new PEP. And return in Python is not always what it seems. And the next obvious question is, if I ask Captain Obvious, how I can avoid return in my code? The answer is, don't use return statement in your code base. Wow, amazing. And next advice, get data from methods by any other legal mechanism. And also, you should explore alternative data flow strategies. Okay, thank you, Captain Obvious. Don't use return in my code if framework allows it. I can do it. For example, some frameworks allow skip return. Django, this is working example how I render template with detail view for one object. Declarative style, I write only statements, and in response I add in context something on init. Init don't return anything by default. In reality, it's return none. And this is example, you don't see any return line there. And this is working example. The next example is I can use context manager. Context manager adds some computed value in context, and this context goes to the next function. It's exactly we call from function which return any value, but I use it with context manager. Context manager, it's preferable to use if we works with some huge objects which should be open, closed. We should release resource. That's why it's not too bad, and we don't have any return lines and any calls. The next, if I don't use return in my code with write tools at first, the framework should allow me to write declarative code. Method like init don't have any return. Context manager helped me to add some value in context. And of course, the best way, if I write a text specification and after that some automatic tools created for me the code. In this case, this is not my code. That's why I don't write any return. And the next step, if return statements simply not needed in my code. In Python or in this life, we have finite state machine paradigm. It's based on states, events, and transitions. We can create the object. In object, it's declared one state. We also declare transition, how one state mutated to other state, probably with conditions. And we also have callbacks on any if it will be called on any transition. And after that, I initiate one object from state machine, and I send event to change transition, to start transition. And state machine example, this is easy. For example, I create the new object in Python, my cute superhero, supercat, and I can send one event, supercat wake up, and after that I ask supercat, how many worlds you rescued today? Nothing. And after that happens event distress call. It was scared voice stream, and after that state of our supercat is saving the world. And after that happens event complete mission. And if I ask, hey supercat, how many things you rescued, or what you rescued, supercat answer me, I rescue the world. And final state machine principles is easy. We working with states of object, and we store information in states. These states can be mutated with transitions, conditions based on states checked in transitions, callbacks called from events, and working with attributes happens through events. I don't return any value in this case. And if return not needed, code contains commands what should be done. Of course, we have more interfaces to work with states than usually in object-oriented programming. By testing, I test only state changes. I don't test any functions. And of course, this example is taken from event-driven architecture, the pattern, event source, and pattern. And if you say me, this is only one example, it's not famous, I can say no, because at first we have libraries PyTransition or Python State Machine. This library offer me to write examples like I showed before. Interesting libraries, dry Python stories or Django service objects. They also offer me to write what should be done, and I should not test what should be returns. The important ideology library Tespian. Of course, Django offer me to work only with states. Logging, it's a famous library. We don't await anything from logging, we only send something. And Celery offer us to work with states of tasks. And right now we go to the important part, any other legal form to get data. The first approach is exception-driven design. Exception result propagation. This is an easy example for the DSF for find one node in graph. In this case, if node find, I raise exception response in the middle of the slide. And happens fast exit. Response not returned in every recursion call. It's thrown exception which carries result to handler. And in this case, exit is faster. For recursions is important. And we have unified form of handler which only use try catch, or sorry, try except. And exception is not exception anymore. This is only container to deliver result for us. There is use it. If you think this is rare, no. PyTest built on this technology. I think coroutine is building on this technology. Deep first search in graphs, parsing, regex algorithm, they all usually use this approach, but not always. Can use. And exception instead of return value. I offer you to use it. There you have many recursion or multiple call stacks. Exception is not more exception, it's only container to deliver value. And usually in those code, more exception classes present. And of course, by testing, I test only which exception was raised. It's easy, it's fun, and PyTest, it's best example for this technique. But the last advice, which I like from Captain Abivius, this is alternative data flow strategies. What it means, we should use generator and coroutines in our code. Coroutine, what it means? I create a function. This function has an infinity loop into this function, and somehow I yield some data from this infinity loop abroad. And function stops on this moment. How I run this coroutine? At first, I should create the generator from coroutine init. After that, I send known to start the first to start this coroutine, and after that I can send signal next to coroutine to read stored value in coroutine, or I can store new value in this coroutine. And this is really interesting. You can never achieve the internal value in coroutine. You can only to work with coroutine through next or send. And this is the first possibility to create really protected attribute, because nobody cannot change this attribute from abroad, only through official interfaces. And this is example how I create coroutine baked attribute in classes. In this case, I create the coroutine method into my object, and I use property to transform function in property, in attribute. And after that, on init, I run this coroutine, and after that, I can set and read attribute which protected from whole world, and I can achieve this. I can change this attribute only through interface. Why there is the benefits for this solution is important. In Python, you know, we don't have any protected or any private attributes because it can be changed. Right now, you can create really protected attribute. And at first, we have also in this solution unified gate for reads and writes. We can add in this gate validation, permission checks, logging, all what you want. At first, as a really protected attribute. And also, it's also observable. I can raise event on every ask from this attribute. It's amazing, but it's still trade not safety, and it's easy solved with error-log. You can ask me if you need it to work with multi-threaded apps with protected attributes through coroutines. Okay, also yield-baked methods. Yield-baked methods can be methods which I can call one time, or method which I can call multiple times. It works the same. I create the method in object. After that, I can get result from these objects, perform some computation and get result through field. And also I can create a coroutine, I can run coroutine, and after that I can send additional value and compute something, and it works faster than standard methods, which every time prepare data to compute some value. And generator or coroutine-based methods, of course, they avoid return line in their body, and they always lazy. We can use delayed calculation. It cached or carried, and some initial values can be stored for future computation. And by default, this is one-time computation. But if it's one-time computation, it leads us to use more efficient algorithms, because it's standard to find in any code some list comprehension, and after that I see how the developer works with lists, and I can see thousand and multiple calls of this list, multiple for loops through this list, and this all breaks your performance of your code and breaks like quality of your solution. And you can ask me, Max, really? You don't have any idea there I can use return? Of course you can use it. You can use return normally. If complexity grows unexpectable, if you start to add some other solution, please use a return. If frameworks or library contract needs await some results, please use a return or return value. For simple helpers, for easy snippets, helpers, decorators, please use a return. And of course, if you work with functional coding paradigm, with clean function, you cannot avoid return. And in this case, please use it. And finally, to use return or not to use. Key takeaways. Return value binded us with structure of returned value and caller who awaited this value. If you change the type of returned value, probably you get the problem. Skip it and enjoy it. Python already offer us returnless solution like side effects and work with side effects and events, to work with exceptions, and to work with yield statement. And if I know which pattern I can choose, of course, also I know, then I can fall back to use return line. And you can try it yourself at home. It's easy. Simply find in your code base one helper or method or function which only mutates state. Find the return line in this function or method and remove it at log instead, and let's see what happens. Probably nothing changes. And in this case, you can understand how to start avoid returns in code. And right now, time to yield question and return answers. Thank you, and yeah, that's all.
Thank you, Maxim, for your talk. And we still have some time for one or two questions. So anyone?
What about performance when you use exceptions?
I already say, if you work with multiple calls, it works faster because result not goes through every stack frame, and it delivers to first catcher, try except catcher. But if you have only one call, of course, usually rising exception It's works slower than return line. Of course, I tested by this QR code. You can find code examples from these slides. Every example is tested, and also I add different benchmarks, memory profiler, and so on. You can test any suggested example by yourself. Play this code by this link.
Okay, let's thank Maxim once more time.
Thank you.